Welcome to JAMA Plus AI Conversations. I'm Dr. Roy Perlis, Editor-in-Chief of JAMA Plus AI and today's host. Welcome to our guest, Dr. Donna Edelson. Dr. Edelson is an expert in cardiac resuscitation at the University of Chicago with a focus on prevention and treatment of in-hospital cardiac arrest. She is the author of Early Warning Scores with and Without Artificial Intelligence, recently published in JAMA Network Open. Donna, welcome.
Thank you.
For our audience, can you describe how and when these kinds of tools are applied? How does this work?
Yeah, the early warning scores are running generally in the background on medical surgical wards in the hospital. And so they're pulling vital signs, depending on the complexity of the model that you're running. They could be also including labs and some other demographics. And so that's the population that they're generally running on, looking at patients who are at risk of needing to go to the ICU or at risk of death.
So what would you say is state of the art now? So are these models just out there running in the background in most health systems?
I would say that most hospitals probably still aren't using any general early warning score. To the extent that people are using them, I suspect that in this country, the modified early warning score is probably the most commonly used of these tools. And in the UK, for example, they're using the National Early Warning Score pretty consistently. So I think that the idea of these tools came from over there. And so I suspect that the adoption is significantly bigger over there than it is here.
And what actually happens when one of these alerts? I mean, I picture sort of the red siren going off, but I gather that's not really how it's implemented.
Yeah, so that's not how we think about this. And I personally am somebody who ignores all alerts that fire in the EHR. They're always coming up at the wrong time. We get so many of them that we have a habit of just canceling them out. And when you actually look at the cancellation data, these alerts, for the sepsis alerts, for example, any health system whose data I've ever looked at, the cancellation rates on those alerts tend to be around 98%. Almost consistently across health systems, which is crazy. And so I am generally not a fan of using any alerts for this. I think about it as a way to risk stratify the patients. So we're sorting them and they're being sorted continuously. So you could essentially see, these are my high-risk patients. These are my moderate risk patients. This is the rest of the population. And then this is really different from a VF alarm, for example, where you need to get in there and respond immediately. This is telling you we're predicting what the probability of someone needing to go to the ICU or dying in the next 24 hours is. So you have time. I wouldn't say you should take 24 hours, but the idea is that it's not a drop everything and run into the room. And that's the kind of thing that needs an interruptive alert. This is the kind of tool that should be running and visible in your electronic health record header. It's right up there with your allergies should be what your risk score is, but it shouldn't be flashing in your face.
And are clinicians using it that way? I mean, is that how these are implemented, or is that more aspirational?
No, I think that's mostly how the general early warning scores are being used. I don't think that's how people are using sepsis scores. And I actually think that the distinction between general early warning scores and sepsis alerts is actually part of the problem and a mistake in how we're doing this. And so I think generally when people are using general early warning scores, they can see the score in the patient list. Some health systems will set them up with alerts.
And are these the sorts of alerts that you can, even when they're implemented kind of in a less intrusive way, do they change your management? So you're staring at the EHR and thinking about, what am I going to do next? If you see a high score, does it shift how you think about the patient? I guess I'm struggling to understand, we're taught to only order tests that are actionable. How is this actionable?
Yeah, that's a great question. And absolutely, they are actionable. And you shouldn't have any predictive algorithm that's not actionable. And so when I set these up, when I work with my own health system and other health systems too, the workflow I generally tend to favor is a patient who is at elevated risk needs more assessment. So high risk is a high touch idea. If you're stratifying the patients, you're thinking, I think of, for example, if Vital signs every 8 hours is the default across the ward population. Different health systems, this one's fascinating to me, but we don't actually know the correct frequency of how often we should be doing vital signs. And so hospitals just do this on their own, different units or different hospitals. Some will say every 4 hours, some will say every 8 hours. I see hospitals that do it every 12 hours. Probably some inpatient psychiatry units are doing it every 24 hours. It truly depends. But rather than doing it based on the hospital or the unit, what makes more sense to me is that we do it based on acuity. So a patient who's high risk, for example, might need vital signs every 2 to 4 hours. Someone who's moderate risk, once we trigger them at moderate risk, I would say you need probably vital signs every 4 hours at least. And then potentially everyone else is fine at 8 hours. And so that's the minimum. One is the question of when you come back and reassess their vital signs. But the next thing that you need to do, and this is where I think the sepsis piece comes in, the idea that we should be screening every patient for sepsis, I think is a mistake. Most patients are not at risk for sepsis. And I think the analogy of it is we used to talk about screen every patient every shift for sepsis, right? That was the original mandate that came down. And that's how we talk about it, which always seemed crazy to me. It's the idea of like, that's the equivalent of getting a pap smear for every adult, no matter of their age or sex, every 10 years. It's both too much and not enough, as opposed to finding the right population for whom you should be doing pap smears and then doing them more frequently. And so that's what I think the value of a tool like this. It risk stratifies patients such that we know how frequently to reassess them. And that's the population that we get more vitals on. That's the population we screen more consistently and more regularly for sepsis.
And can you give us a sense, either based on the paper or just based on your experience? I mean, what's driving these models? What are they doing that you as a clinician can't do?
What humans do really well, I think still better than machines can do, is what the attending does. When the attending comes in the room and just has that sense of sick or not sick, right? At this point, I attend on the wards only 2 weeks a year. And the one thing that I can do is I can walk in the room and I can look at a patient and say, oh, this patient is not in a good space. This one needs attention right now. Whereas sometimes my new interns may not be as adept at that.
And do you think that that sort of sense that you have, like, does that correlate with what the algorithms are giving us, or are you picking up on different things?
So I think there are things, so I was going to say that piece, the machines haven't replaced that. Maybe someday they will, but right now, I'm not at the bedside of all the patients. When I'm on service, I do rounds in the morning. I might come back at the end of the day and see 1 or 2 patients if I needed to, but generally, the house staff are taking care of the patient the rest of the day, and they're there at nights, not me. And so the value of a tool like this is it prioritizes which patients are going to get more attention. Ideally, we wouldn't have deterioration or failure to rescue events in the hospital if I could put a critical care attending at the bedside of every single one of the patients in the hospital. We'd be good. We wouldn't have any failure to rescue events. We can't afford that.
So, in AI and computer science, we love a good bake-off. And I'm kind of curious, like, what made you decide to do this comparison? So we've been talking generally about models and what they're good for, but what made you sit down and say, we really should do a head-to-head of these things and figure out what's better or worse?
This is a question that people ask all the time because everyone's trying to figure out what tool they should implement. And I guess the first thing that I would say is it really matters. The quality of the tool matters because we want high sensitivity. We want to catch these patients that are deteriorating. It's literally life and death. So we want a tool that has high sensitivity, but deterioration is still a relatively rare outcome. If 5% of the patients are gonna deteriorate in the hospital, that's both a lot, if you think of your hospitalized patients, and statistically a little, which means that the false positive rates can be really high if your model isn't great. So if in order to be able to pick up at least half of the deterioration events, if the tool isn't good, you're going to have a lot of false alarms. And that's the alarm fatigue that you get into. And then no one's benefiting at all. So people want a tool that they want to be able to have a tool that minimizes false alarms, but also it's really hard to do these analyses, and especially to be able to do a head-to-head analysis. Usually people have just one tool that they can compare. What was really unique about the Yale team is that they had 3 different advanced AI models in the same data set. That's pretty unusual. And then also the others could be easily, anybody can calculate Muse and News. And so, but the ability to be able to have 3 proprietary tools and be able to look at them head to head, that's pretty unusual.
How do we get more of this kind of work? What needs to happen to make this stuff more common?
Well, it's tricky when the models are proprietary models. And also, there's privacy issues. These are massive data sets. And so there's concern from health systems in terms of sharing that amount of data. And also from companies that are going to push back, I think, in terms of putting the models out publicly. I know that from my own experience on the commercial side as well. So I'm not sure that we're going to see tons of these head-to-head of proprietary algorithm comparisons against each other. But I think that the study that would have 20 of these head-to-head to head-to-head, I think is a little, I can't picture it yet. I'm sure folks are working on trying to figure out how we could do it. But I think more realistic, what I think we can do today is set a default for each one of these tools that we're going to look at. And because I think if at least you can use a tool that anyone can calculate, something like the News, for example. And I think that's part of what we were arguing in this paper, that the News should be the new default for general early warning scores. And so while you might not be able to compare the score that you're building to eCart head-to-head, you can compare it to News. And you can use those same thresholds and look to see how it stacks up at the moderate and the high-risk threshold. And then also we can see when those results are published, whether the data set that you were using was comparable. Because there's so many things that will affect it. For example, if you're only using med-surg patients, or if you're including step-down in there, or if you're including ED patients in there, or postpartum patients, all of those things and the mix of it will change your AUCs, your positive predictive values. But at least if you have something that's stable and consistent, like the News, we can at least understand what your data set is representing.
So it makes these more comparable. Because I think you had 7 hospitals in your paper. I mean, that's setting the bar pretty high, but I do suspect people are going to say, well, if you look at it in my system, the performance would have been different. I'm curious, were you worried about publishing this? Did you think you'd get grief from someone behind the models to say, well, you did it wrong, or, that's not fair?
Well, we tried in publishing this to be as fair and as generous as we could be. And I think that's important to do. So one of the things that we did was make sure that the time points aligned. And we aligned them to the Epic Deterioration Index. And so that favors that tool because so if that's the tool where that score is most common and we align it to that one, I think that's important. The other things that we do is just while we were primarily interested in the outcome of deterioration in 24 hours, we ran it for the outcome of mortality as well. And we looked at 12 hours, 48 hours, lots of different approaches, I think, to counter that concern. But none of that mattered. The truth is that what we saw with the original analysis was consistent in terms of the trends for the most part across all the hospitals and also all the scores.
In terms of those scores, I'm wondering if you're a patient, how should you feel about whether a hospital is using these models or not? Like, is this the sort of thing that someone going into the hospital should worry about? They're using this system or they're not using this system. Which one are they using? Because a lot of the discussions, we talk at the health system level or the folks developing these tools, but ultimately there's a lot at stake here. So from a patient point of view, is there something to take away from this paper?
I personally feel if I'm going to be hospitalized, I personally would rather be in a hospital, and I would rather that I think about my mother, I would rather she be hospitalized in a hospital that is running a general early warning tool. But it's not just the score. And I think that that's really important because what you need is a whole system. The predictive analytic is one component of an overall system that's trying to find deterioration early and respond. You need to have the best tool that you possibly can be running because you don't want a ton of false alarms, number one. Number two, you need that score to be visible to the front lines in the workflow where they are. So it needs to be prominently displayed in the electronic health record because that's where providers are. It might need to be on a board. And then three, they need it to drive a workflow. And that workflow needs to have the patients reassessed, have them screened for sepsis. And then if when you get to the bedside, those clinicians, that rapid response nurse, the attending physician who comes then to the bedside and looks at the patient and says, boy, yeah, this patient really is deteriorating. Well, now you have to have a way to get them resuscitated if they need to be resuscitated, moved to an ICU. All that needs to happen. And if you are missing any of those pieces, then it doesn't matter. You could have had the best algorithm in the world and no one's doing anything with it.
I'm Dr. Roy Perlis, and I've been speaking with Dr. Donna Edelson from the University of Chicago about risk models aimed at predicting clinical deterioration in hospitalized patients. You can find a link to the article in this episode's description. To follow this and other JAMA Network podcasts, please visit us online at jamanetworkaudio.com or search for JAMA Network wherever you get your podcasts. This episode was produced by Daniel Morrow at the JAMA Network. Thanks for joining us.
This content is protected by copyright by the American Medical Association with all rights reserved, including those for text and data mining, AI training, and similar technologies.